Hello students, we are going to learn about the regular and non-regular grammar. See, according to Chomsky hierarchy in the theory of computation, grammar are divided of four types. One is a type 3 grammar, type 2 grammar, type 1 grammar and type 0 grammar. Type 3 grammar is called regular grammar, type 2 grammar is called context free grammar, type 1 grammar is called context sensitive grammar, type 0 grammar is called unrestricted grammar. We will see it one by one. Okay, now see, a regular grammar, also called type 3 grammar, generate regular language, and this regular language is accepted by finite automata. Context free grammar, called type 2 grammar, generate context free language. This context free language is accepted by push down automata. Context sensitive grammar, called type 1 grammar, generate context sensitive language, is accepted by linear bounded automata. Unrestricted grammar, called type 0 grammar, generate recursive enumerable language, and this recursive enumerable language accepted by Turing machine. We will see it one by one, but before type 0, 1, 2 and 3, we will see what is the grammar and language. See, uh, suppose this grammar is grammar. What is grammar? Grammar is defined by four tuples v, t, s and p. V is a finite set of variables, also called non-terminals. T is a finite set of terminals. S is a special symbol called star, also called star symbol. P is a finite set of productions. Okay, and every production is in the form of alpha tends to beta. Okay, and this is the left hand side of the production, and this is the right hand side. This is the right hand side of the production. Okay, we read it as a alpha tends to beta. Okay, in place of alpha we can write any combination of variable and terminal, and in place of beta, in the right hand side of the production, we can write what we can write. We can write any combination of variable and terminal, including epsilon. Here excluding epsilon. Okay, in the left hand side epsilon means lambda is not possible, while in the right hand side, this is the right hand side, in the right hand side epsilon or lambda is possible. See, in the example, suppose uh, this example is given, and this is a grammar. Say that this is a grammar G1. Okay, you can say anything, G1, G2, G3. Consider this is a grammar G1. Okay, in this grammar, how many grammar is defined? We know that grammar is defined by four tuples. One is variable, second is a terminal, third is a star symbol, fourth is a production, a set of productions. Variables, variable is always variable is represented by non capital letter, and terminal is represented by a small letter. And see, how many variables are there? There are three variables: capital S, capital A, capital B. There are three variables given in this grammar. And terminal, there are two terminal, small A and small b, and S is a star symbol. What is a star symbol? In a given grammar, we will see the first production. In the first production, we will see the left hand side of the production. This is the left hand side of the first production, and the left hand side of the first production is called star symbol. Suppose in place of capital S, it is X, then X is a star symbol. If it is a capital Y in place of S, then Y is a star symbol. Okay, so first we'll see the first production in a given grammar. In a first production, left hand side of the first production is called star symbol. Okay, now P, what is P? P is a set of production. How many production is given in the given grammar? In a given grammar, there are three production. S tends to AB, A tends to small a, B tends to B. Okay. First we'll take S tends to AB. S tends to AB. In place of capital A, we can write small a. Okay. Now this is the step 1. of the derivation, and this is the second step of the derivation. Why we can write small a in place of capital A? Because it is given that A tends to A. This is given in the grammar, means we can write a small a in place of capital A. So put a small a in place of capital A. So this is the second step. Now see, in place of capital B we can write a small b in the third step. Why? Because in a given grammar it is given that capital B tends to B, means in place of small b we can write, in place of capital B we can write small b. So put small b in place of capital B. So now string AB generated. So we can say that language of grammar G1 equal to AB. Okay, so what is the language of this grammar? The language of this grammar is AB. What is a language? Language is a set of string. We know. What is language? Language is a set of string. So this string is generated by this grammar, and only one string is generated by this grammar. So in this set, only one string is there. So what is the language of this grammar? The language of this grammar is AB. Okay. Now see example 2. Here the one another grammar G2 is given. S tends to AB, A tends to one another grammar is given. Say it is G2. Okay, we can say anything. Consider this grammar, and the name of this grammar is G2. Suppose that S tends to AB, A tends to A, lambda, and B tends to AB. There are three production is given in this grammar. So how many non-terminal is there in this grammar? There are three non-terminal: capital S, capital A, and capital B. Terminal symbol, there are two terminal symbol, small a and small b. And S start, which one is start symbol? We'll see the first production. In the first production, we'll see the left hand side of the first production is called a start symbol. So S is a start symbol, and P is a set of productions. There are three production is given. S tends to AB, A tends to lambda, and B tends to AB. So P is a set of productions. So see. Can we say that small ab is a sentence of this grammar? First we'll see in using derivation. So take first production, S tends to AB. Now we can put lambda in place of capital A, because it is given that A tends to lambda, means in place of capital A we can write lambda. So put lambda in place of capital A. Now this is the first step, and this is the second step, lambda b. Now in place of capital B, can we write AB? Yes, we can write. Why? Because it is given that B tends to AB. So in place of capital B we can write AB. So put AB in place of capital B. Now it is lambda AB. We know that lambda concatenate AB equal to AB, means this grammar also generate AB. So language of this grammar is AB. So we can say that for one language more than one grammar is possible. For one language more than one grammar is possible, but for one grammar there is only one language. For one grammar always there is only one language, but for one language more than one grammar is possible. See, this is the language, this is the language of the grammar, this is the language of this grammar, and the same language for this different grammar. So we can say that for one language there is more than one grammar is possible, but for one grammar always there is only one language, right? See, what is it? We know that language is a set of string. See, in this given grammar, this is a grammar. Okay. In this grammar, only two production is given. S tends to A as B, and S tends to lambda. Okay. Now we'll see the derivation. We'll take the first production, which have a start symbol. Okay. S tends to A as B. S tends to A as B. Now, if we put we can put lambda in place of capital S. Definitely we can put. So put So we put lambda in place of capital S. So it is a lambda b. We know that a concatenate lambda concatenate b equal to ab. Okay. Now, but if in place of capital S, in place of capital S we can put ASB, in place of capital S we can put lambda also. But if we put, but in place of capital S, if we put ASB, in place of capital S, if we put ASB, then it is ASB in place of capital S, then it is 2 time A S 2 time B. If we put lambda in place of capital S, then it is AABB. Means one string AB generated by this grammar, another string AABB generated by this grammar. But if we put ASB again in place of capital S, then it is ASB in place of capital S, that is 3 time AS 3 time B. Now if in place of capital S if we put lambda, then it is 3 time A 3 time B. But if in place of capital S if we put ASB, then again ASB, then it is 4 time A 4 time B. And if we put lambda in place of capital S, then it is 4 time A 4 time B. Similarly 5 time A 5 time B. Means what is the language of this grammar? S tends to lambda, so we put here lambda. And then this AB is also generated by this grammar, so put AB. AABB is generated by this grammar, so put AABB, or you can write A square B square. And A cube B cube, A 3 time B 3 time, A 4 time B 4 time, and so on. So this is the set of string. Okay, and set of string is a language. So this is the language of this grammar. And this language, this set of string is we can also write like this: language of the grammar equal to a ka power n b ka power n such that n is greater than equal to 0. Okay. See, this is the grammar G1. A, S tends to ASB, S tends to lambda, and G2, S tends to ASB, S tends to lambda, and A tends to A, B, and A tends to lambda. Using grammar Z1, this is the grammar Z1. S tends to ASB and S tends to lambda. Using this grammar, what is the language of this grammar? Yes, language of this grammar is a ka power n b ka power n such that n is greater than 0. Okay, means the language of this grammar is a ka power n b ka power n. Language of this grammar G1 is a ka power n b ka power n such that n is greater than equal to 0. Now what is the language of this grammar G2? See, what is the language of this grammar? S take a first production which have a star symbol. S tends to ASB, S tends to ASB. In place of capital A we can write lambda. Why we can write lambda? Because we know that A tends to lambda is given in this grammar, means we can write lambda in place of A. So put lambda in place of A, then we get AB, means AB is a sentence of grammar G2. But if we put A, capital A, B in place of capital A, then it is A 2 time A, B, capital A, B 2 time. And now if we put lambda in place of capital A, then it is A 2 time, B 2 time. Okay. Now see, in place of capital A, if we put again AAB, then it is A 3 time capital A, B 3 time. And now again put lambda in place of capital A, then it is A 3 time, B 3 time. Means this grammar G2 also generate lambda AB, AABB 3 time A 3 time B. Means the language of G2 is again also A power n B ka power n such that n is greater than equal to 0. Means language of grammar G1, and equal to language of grammar G2. Okay. Now see. Suppose this is a grammar. This is a grammar G1. Okay, we can write this grammar like this: S tends to ASB, S tends to lambda, and this is called derivation. This is called derivation. We'll take the first production. S tends to ASB. In place of S we can write lambda, because S tends to lambda means in place of lambda we can write S also. So put lambda in place of S, then it generate AB, means AB is a sentence of this grammar. Okay, but if in place of S you'll write ASB, then it is ASB. So 2 time AS, 2 time B, it generate and in place of capital S we put lambda, then it generate 2 time A, 2 time B. Okay, similarly, if in place of capital S we write ASB, then it is ASB, then it is 3 time A, and in place of capital S if you put lambda, then it generates 3 time A, 3 time B. Means what is the language of this grammar? The language of this grammar is lambda comma AB comma AABB comma 3 time A, 3 time B, and so on. This is the language of this grammar. Okay, similarly the grammar Z2, this is the derivation. If you will derive, take first string and put this product in place of capital A, put small a, capital A, B. Okay, in place of capital A put lambda, then in place of capital A again put AB. Then you'll see that using this grammar also generate lambda AB, 2 time A, 2 time B, 3 time A, 3 time B. So language of this grammar is also a ka power n, b ka power n, such that n is greater than equal to 0. That's why I am saying that language of grammar Z1 equal to language of grammar Z2. Okay, now see here one more example is there. A tends to AA and A tends to small a. Here take first production. A tends to AA, A tends to A. In place of small capital A, what we can write? In place of capital A we can write small a capital A, or we can write small a. Okay, just put small a capital A in place of capital A. If we put small a capital A in place of capital A, then it is 2 times small a and capital A. Again put small a capital A in place of capital A, then it is 3 times small a and 1 capital A. Again put small a capital A in place of capital A, then it is 4 times a small a and 1 capital A. Okay, now see, A tends to A means A is also sentence of this grammar. Okay, because A is a start symbol. A is a start symbol. Okay, so A is a sentence of this grammar. If we put small a in place of this capital A, then it is 2 times A. If we put small a here, then 3 times. Okay, single a, 2a, then 3 times a, 4 times a, and so on. So what is the language of this grammar? Language of this grammar is a plus. Okay, and we know that a plus equal to a power 0, a power 1, union a power 2, union a power 3, union a power 4. This is power 1, this is the power 2. Okay, a power plus equal to a power 1 union a power 2, a power 3, a power 4, and so on. Okay, so we can write like this: e ka power n such that n is greater than equal to 1. If we put 1 in place of n, then it is a 1, then it is a single a. If we put n equal to 2, then it is a 2a. If we put n equal to 3, then it is a 3a. If we put n equal to 4, then it is a 4a, and so on. So the language of the language of this grammar is a, 2 times a, 3 times a, 4 times a, and so on. And this is a set of string. This is a set of string, and this set of string is called language. So the language of this, what is the language of this grammar? This is the language of this grammar, and we can write a plus in place of this, we know already. Okay, and in place of a plus also we can write like this: a ka power n such that n greater than equal to 0. So language of this grammar is, what is the language of this grammar? The language of this grammar is a का power n such that n is greater than equal to 1. Okay, now type of the grammar. There are we already know that there are 4 type of grammar: type 3 grammar, type 2 grammar, type 1 grammar, type 0 grammar. Okay, now in this lecture, the next lecture, we will see what is the type 3 grammar and type 2 grammar. Okay, thank you.